I want wormholes everywhere. Like in the back of your refrigerator connected to your grocer.
Okay, now you're going Homer Simpson on me. No!
Wouldn't it be fun if we were just the nth intelligent civilization to rise up on planet Earth? I think we would see a record of this somewhere in the fossils.
Right.
There'd be a Statue of Liberty sticking out of the ground.
Damn you! Damn you all to hell!
StarTalk, Cosmic Queries. Oh, yeah. Chuck.
Hey.
You going to help me out here?
Of course.
Yeah. You know, I never see these questions in advance.
No, you don't.
They come from our Patreon supporters.
The people who are
entry level.
Yes. That's all it takes is $5 a month, and we...
it's been $5 a month for years.
And you know why? Because we don't believe in inflation, unlike some other people.
So, is there a theme today?
Nope, this is a grab bag.
Just random.
Whatever they want.
Ask me anything.
Let the people speak and ask.
Okay, let's get right into it.
Inquiring minds want to know. Here we go.
Let's get right into it.
Okay, Eric44 says, "Hey, legends. Eric here. Exercise physiologist and space flight physiology researcher from New York City."
Love it.
Look at that.
Love it.
He says, "My question is, all motion requires time, but does all time include motion?"
I would say the measurement of time requires not only motion, but something that repeats.
Okay.
Think about it.
Right.
Have you ever measured time with something that did not repeat periodically? The answer is no.
No, you can't.
A day repeats every day.
Right.
Seconds repeat. Everything repeats. Months repeat.
Yeah.
Years repeat.
Right.
So where there is no repeated motion, there can be no coherent measure of time. All you'd be able to do in your own reference frame is sequence events. This came before that,
This,
before that. Right. And
I remember in the before 4 times.
no, the before 4 times.
Right.
I'm older than you. I'm
Right.
Before 4. So now the sequence of events can be different depending on your reference frame relativistically. You could be moving in a different direction and you'll experience those events in a different sequence than I will. But in my reference frame, like I said, if nothing repeats, time cannot be measured.
Right.
With any meaning or repeatability. So it's a fun, interesting philosophical question.
Yeah.
But space can exist without a time, I would think. Space doesn't need time.
No, it doesn't. I mean, space is
there.
like, I'm here. I'm not going anywhere.
You want to measure something? That's your business.
That's what for you. I don't care what you measure. I'm right here.
So there you go.
That's very cool. Well, there you go, Eric44.
Well, I answered that quickly.
That was a great one.
Wow.
Well, we're off like a rocket. This is Maurice Backer. Says, "Dear Lord Nice, dear Dr. Tyson, I am Ilyada from the Netherlands, and I am 12. My question is, what is the one book that every 12-year-old should read? And my name is pronounced Elida." Oh, okay. Thanks for the phonetic there, Elida.
He knew in advance.
I called you Ilyada, and yada, yada, yada. Anyway.
Stop.
No. Okay, Elida, and I didn't get it right. She asked, I should read these beforehand. Anyway, universal respect and greetings.
Delightful. What a mature 12-year-old.
What a very mature 12-year-old.
That's clearly not written by an American kid.
Without a doubt, Yeah.
So I'm very biased here because I only write books that I think people should read to get them enlightened about the universe.
Okay.
And I find gaps in the publishing landscape.
All right.
Scientific landscape. I say, I'm going to bridge that gap.
I'm going to put something there.
I'm going to put something there.
Right.
So I can say at age 12, writing like that, and plus the Dutch, they're fluent in English.
Yeah, well.
I mean.
Yeah, without a doubt.
Okay, so.
Even though they're free to.
No, that's not Dutch.
I know.
No, you're mixing that up with the Swedes.
With the Swedes, I know. But it's funnier when, Like Dutch is actually that's actually Dutch, but it doesn't make for a funnier, it makes for a funny joke. But anyway, you're right.
My book, Astrophysics for People in a Hurry,
Okay,
has a young people's version of it called Astrophysics
for young people in a hurry.
Now, I keep thinking young people should never be in a hurry.
Yeah, well, they got to get back to them video games. You know what I mean? I gotta read this book quick because Valorant is waiting. Halo ain't gonna play itself. Gotta get back to the video game. Let me see what Neil says before I get back to Roblox.
So that book was conceived for ages 8 to 12.
Oh, wow, cool.
Which collectively is called the tweens.
Right.
And its value is, it's not just that is it dumbed down. No, it folds in a lot of my own background when I was that age, because I was a geek kid. Mm-hmm. And so you get to sort of live with me through your own years that you're reading the book.
That's cool.
Okay. So it might have still have value to a precocious 12-year-old.
Right.
But if not, then just go right to Astrophysics for People in a Hurry. It's not astrophysics. It's real astrophysics.
It's astrophysics.
It's astrophysics.
Right.
But I have cherry-picked it for the coolest stuff in the whole universe.
Right.
And that's what's there. From Big Bang.
I call it the book you should read when you don't really want to know the granular details, but you want to be able to have a cool conversation at a cocktail party.
That'll totally equip you to do so.
Exactly.
So there's that. But then, if it just wants to have fun, definitely the Merlin book.
Oh, okay.
Merlin's Tour of the Universe. It's a Q&A. He's asking a question and answer right now. Yeah. It's illustrated by my brother.
Oh, cool.
It's just I think it's a fun book. So forgive me for recommending my own books.
For shamelessly promoting myself. No, you're supposed to. That's great.
Yeah, it's not shameless. I'm doing it with complete
No, you're
shame.
doing it with right. I know what I'm doing. Ain't no shame attached here.
So I think he will enjoy those. I'm certain of it.
Okay.
Because they're written with that in mind. That's all.
Right. Now, is Elida a boy's name or a girl's name? I don't know.
I don't know. He or she. Elida?
Elida. Yeah.
Okay, let's degenderize it.
Yeah, we'll call them they.
They. Yeah. So, Elida, sorry to misgender you, if in fact that's what I did.
Right.
But I think any of those three books will, as Chuck said, you can get some good reading in between video game playing. Right, okay. Halo ain't going to play itself.
There you go.
All
right. Here's Andrew Bowen. I'm riding at the edge of our universe since the Big Bang and moving with the expansion. What does it look like when I'm facing back at us? And what does it look like when I'm facing outward ahead?
It looks just like it does here and now.
Ooh.
We are at the horizon of anybody who's at our horizon.
Exactly.
And anybody at our horizon sees the universe all around them like anybody else does.
There you go.
Yeah.
Yep, that's right.
So what would happen is if you, imagine this instant, go to our horizon in this instant, light from us emitted 13.8 billion years ago is only now just reaching you.
Right.
You will see all of us as galaxies being born.
Right.
So this would be your horizon.
That's what it is.
That's how that works.
So yeah, that's so cool.
We are all equally as far away from the origin of the universe as each other.
It's like being in the middle of the ocean.
Yes.
Yeah.
You go to your horizon, you're still in the ocean.
You're still in the ocean.
Right.
That's so cool. Mm-hmm. Wow, great question, Andrew. I love it.
Oh, by the way, we don't know how far the universe extends beyond our horizon.
Right.
Just the way there might be a point where land shows up, no matter how big the ocean is.
Right.
So there might be a point where you run out of galaxies in the universe.
And stuff, right.
Right.
But we don't know that because
every direction we look, we see galaxies being born.
Exactly.
So we are deep within a space-time continuum that's much larger than our own bubble.
Man, that's so.
But you know what happened?
Right.
If one day the cosmic microwave background disappears.
Uh-oh.
And that would mean that our horizon, which is expanding at what rate?
Well, it's got to be. Well, suppose isn't it faster than the speed of light?
No. Just visual horizon. It's expanding at 1 light year per year.
Right.
So in a billion years, will be 14.8 billion years to our visual horizon. All right. So the point is, if the cosmic microwave background disappeared,
right,
and then you just see galaxies up to that edge, that means our horizon is washing over a part of the universe where there is no matter. There are no galaxies.
Oh.
And we would have reached the edge of any material substance in the universe.
Right, because now wait, is that because we're traveling?
No. Our horizon is continuing to move out.
Oh, because it's moving out. It's moving out.
So it will always find a galaxy being born.
Right.
Okay? Until it doesn't.
I gotcha. And so, once we get past that, that means nothing's there.
Nothing's there.
Oh,
correct.
Snap.
That's finally getting beyond the ocean and land.
Right.
Yeah.
All right. Wow, that was cool.
In a show like StarTalk, we jump from black holes to biotech to brain chemistry because science is both complex and interconnected. But we don't just throw ideas at you. We organize them, frame them, and make sense of how they fit together. That's exactly what Ground News does for the news. Instead of just feeding you headlines, it zooms out, showing you how stories are being reported, who's reporting them, and what's being left out. Like a telescope for the media landscape, it helps you see not just the brightest signals, but the whole constellation of perspectives. Think of it like a peer review for the news. Instead of just trusting one headline, Ground.News lets you track the evidence and form your own conclusion based on the full picture. And right now, StarTalk listeners can try the top-tier Vantage plan for just $5 a month, which is a 40% discount. So, if you're into science but lean a little skeptical and want to see the whole story, head to ground.news/StarTalk or scan the QR code to subscribe. Stay curious and stay grounded. Now, back to the show.
So let's go to Young Han. Young Han.
Spell Young.
Y-O-U-N-G.
Okay. Mm-hmm.
Young Han, who says, Mr. Tyson, I love your work and your show. Can you talk about the Silurian Hypothesis and how it impacts how we should view our own species, civilizations, and specialness or lack thereof here on Earth? If advanced civilization is so fleeting and difficult to detect in our own fossil record, is it going to be easier or harder to detect in space?
Wouldn't it be fun if we were just the nth intelligent civilization to rise up on planet Earth? Or even the nth civilization of humans that had rose up
And
destroyed themselves, rose up again multiple times.
Right.
So I think we would see a record of this somewhere in the fossils.
Right.
You'd think.
Right.
There'd be a Statue of Liberty sticking out of the ground.
Damn you! Damn you all to hell!
You apes! There'd be. I mean, that's an example of a Silurian civilization that predated the planet of the apes, because that was Earth.
Right.
Okay. It seems to me we would find a record of it. But if we find bones, we find other fossilized artifacts of dinosaurs from 65 million years ago.
Right.
Then, and by the way, the biggest mammals of the day were these tiny little rodents running underfoot, trying to not get eaten by T-Rex as hors d'oeuvres.
Yeah.
Okay. So you can't presume that there were big brain mammals before that, because that was the origin of the mammals on Earth.
Right.
Around that time.
Right. Is there a possibility that the civilization before us were not mammalian?
Okay, so I haven't seen any like dinosaur casinos or anything left over. No, I mean, just you would see things.
Right.
We're not ignorant of the history of what happened in Earth's crust. Here's where you'd have a problem.
Go ahead.
You can ask the question, what is the time scale for all of Earth's crust to get subducted back down and come out in a volcano.
Oh,
because that would destroy all evidence.
Right, all the evidence would be gone because it become molten, and then it would spew out again and cover the Earth.
Completely gone.
Right.
Okay, so different parts of the Earth are younger than other parts.
Right.
Like the middle of Iceland is brand new.
Right.
Like made yesterday.
All of the big island of Hawaii.
Iceland is on the mid-Atlantic ridge that is spewing out. I visited there recently.
Yeah.
It's this is a whole new land between where I was standing and another ledge on the other side. And I did the math because continents drift about the rate your fingernails grow.
Oh, wow.
So I did a fast, and I calculated how many millions of years that would have taken. But still, it's new land compared to other places.
Okay.
You go to places where it's not regenerated that rapidly, and you don't find other evidence.
Okay.
So
yeah. Yeah, it's very unlikely, unless the dinosaurs were like the ABC TV show that used to be
what's he show
called Dinosaurs, where you never saw that?
No.
I just remember it was a little dinosaur, and whenever
I just remember the cartoon Land Before Time. I remember that one.
Yeah, A Land Before Time. Do I know that one?
It's a cartoon movie. Yeah.
I don't think I know that one. But yeah, dinosaurs. There was like
they were just living.
They were just living like regular human beings. They had jobs. Everybody worked for one corporation called the We Say So Corporation. And
how did I miss this?
Yeah, and then there was one little baby dinosaur, and every time his father would come in the room, he would jump on his head and hit him with a pot and go, "Not the mama, not the mama." In other words, like, I don't want you. Get me, mom.
So this is like the Flintstones, except they're dinosaurs.
Yeah, that's it.
It's a whole world
a whole world just like the Flintstones, but all run by dinosaurs.
Okay.
Yeah. It was a pretty wild little show back in the day.
Okay. There's the thing about like the size of their brains. You know, there's an issue there.
Oh, okay.
Just the higher levels of thought.
That might not be resident in a dinosaur whose brain is.
It's an intriguing idea.
Yeah.
And I think we would see evidence of it, and we don't.
Gotcha.
And so in that case, the absence of evidence is evidence of absence.
Ooh, I love it.
Which is not always the case.
Not always the case.
Yes.
All right, this is James H. English, who says, "Hello, Dr. Tyson, Lord Nice. It's James from Denmark." By the way, James, we apologize. We're so sorry. And, all this talk of Greenland, we have nothing to do with it, okay? We're just letting you know. All right? It's like, it's like our uncle got into the liquor cabinet while he was on his meds, and now he's just sitting in a chair going, "I know we should buy Greenland. That's what I think." So I'm sorry. So here's what James says. I heard on a previous episode that what we think of as singularities at the heart of a black hole may not actually exist. But I'm not sure I understood. We know black holes exist, but what does it mean to say the singularities may just be mathematical artifacts?
Yeah, good question.
Love these. Pretty wild.
So if you just follow general relativity math,
right,
the object collapses under its own weight.
Mm-hmm.
As it collapses, the gravity on its surface continues to rise. It reaches a point where the gravity on the surface has an escape velocity greater than the speed of light. At that point, light does not escape, but it continues to collapse. When we talk about the size of a black hole, functionally, we're talking about the size of the event horizon.
Mm-hmm.
But inside the event horizon, all bets are off. So the matter keeps shrinking. According to the general theory of relativity, the gravity is so severe that nothing can stop it, and it shrinks to zero volume.
Yeah, right. And wow,
and that's just crazy. What does that even mean?
Yeah, what does it mean?
We all presume that there's some other law of physics that's going to prevent that, but that calculation is at the limits of the applicability of the general theory of relativity.
Gotcha.
So that's why we know in advance that the general theory of relativity has limits.
Right.
Limits to its applicability.
There you go.
Right. Whereas quantum physics have yet to find a limit.
Right.
And we got smart people on that frontier, string theorists, who are trying to send the math into that singularity to try to resolve that problem. And
because if you do, then you reconcile general relativity with quantum physics.
Yes, you will.
Yeah. That's pretty wild.
Yeah. And more playfully, this fact that it goes to 0.
Right.
Some people say that's where God divides by 0. Because
Okay.
remember, you're not supposed to.
You can't do that,
Yeah,
or you're not supposed to do
You
it.
can't divide
Right.
by 0.
I still don't know why. I'm just like,
Have you tried it?
because 0 divided by 0 is I got nothing.
No, that's undefined.
Right. That's my point, but I can define it. I started with nothing. I divided nothing. I got
Nothing from nothing
There you
leaves
go.
nothing.
That's a good song.
Okay,
Nothing
thank
from
you,
nothing
Billy
leaves
Preston.
nothing.
When I first heard that song, I said, "Really? Is that the best math you can give me in this disco era?" I was in high school when
Yeah,
that came
everybody
out.
was high on cocaine.
Oh.
They weren't trying to do
It's
math.
like, who are you trying to impress with this math here?
Certainly.
I can hook you up with some good formulas.
Oh, that's so funny.
Okay.
Okay, here we go. This is Michael Trilling. He says, I'm an artist and I have been working in stained glass recently.
Ooh.
It had me thinking, how can light travel through some materials but not others? What makes something transparent at an atomic level?
Yeah, so I don't have a good answer for that. I have an answer, but I know in advance
It's not good.
correct. So I'm giving like a just so answer.
All
to
right.
it, okay. So transparent media, there's nothing to change the pathway of the light through the medium, and so it maintains a straight direction.
Okay.
Okay, and so it comes out the other side. You see whatever was on the previous side of that material. If the structure of the lattice or the molecules or the atoms is such that the light is either absorbed or dispersed, because it can still be transparent to light, but you can't see through it.
Right.
What's the word for it? Translucent?
Translucent. Right.
Okay. Light still gets through,
Frosted glass.
but frosted glass. But the path the light took was varied, and so there's no coherent image that comes through to the other side.
gotcha.
But here's a little known fact. As this person surely knows, light travels slower in a medium than it travels in a vacuum.
Right.
It travels slowest in a diamond, which helps it internally reflect so that when light comes in from one direction, it pops out a different direction.
Right.
When it's cut, when the facets are just right.
Right.
So that's why diamonds have a certain radiance of their own
Right.
when they're just really messing with the light that came in.
So Rihanna was wrong. It's not shine bright like a diamond. It's just refract light like a diamond.
What was that from? Ocean's 8?
No, she
a song?
has a song, Shine Bright Like a Diamond.
Oh, sorry, I didn't know that. Yeah,
Everybody
it's not
loves
shining.
it.
It's not shining.
Yeah, it's not shining at all.
Right.
Yeah,
Is that why they put her in Ocean's 8?
probably. And she's Rihanna.
Okay. Okay, couple more. Go.
All right, here we go. Alex Romillion says this. Greetings, Dr. Tyson and your ragtag team of lifelong learners. I'm Alex from Northeast England. My question, there's a lot of talk about mining the moon. Wouldn't that be a bad idea, considering if we're transferring mass from the moon to Earth, we won't make the moon lighter because of the gravitational effects it has on Earth, i.e. the tides? To weaken over time and eventually stop, what other effects could it have? Regards from a lifelong learner.
I love it. And I love lifelong learners.
Yes.
Thank you for checking in.
Yes.
Okay. Couple of things.
Couple things.
First, two things. So it is likely that whatever we mine on the moon will stay on the moon or go to other places in the solar system where we're doing work.
Right.
It's not likely that the moon has something so valuable that we need to
want to
bring
it back to the Earth.
Especially since the moon was carved out of our crust in a collision between a Mars-sized protoplanet and Earth.
Right.
It sideswipes up, our crust goes into orbit, coalesces to form the moon.
Right.
And so the moon it's our crust.
That's probably not too valuable.
No, it's not too valuable. Not too valuable.
Yeah.
To go there and then bring it back. So now, but suppose we did. Suppose we mined 100% of the moon.
All right.
Brought the whole damn moon back piece by piece.
I love it.
Okay? All right, we still have tides
Right.
from
The sun.
the sun.
All right, because
Sun tides are about a third as strong as the moon tides.
Right.
All right, so you still have tides. Not as big, not as bodacious, but you still have tides. How much heavier does Earth weigh? The moon is a little more than 1% the mass of the Earth.
oh, that's nothing.
That's nothing.
I ain't doing that.
That ain't doing it.
That's a
Like if you weigh
a
100,
mosquito on an elephant.
so if you weigh 100 pounds on Earth, you'd weigh 101 pounds and a little and change.
No, that's barely
And you
worth.
fluctuate that
That's
just
not worth the trip.
between meals and between poop.
Right.
Okay, you fluctuate.
Yeah,
more
that
than
happens to me every morning. You know what I mean? Get up on the scale like, damn. Go to the bathroom. All right.
So yeah, it's not. Don't worry about it. Yeah, it's a big moon, but Earth is even bigger.
There you go.
We good.
All right. This is Bas Oosterveld. And Bas says, greetings, Dr. Tyson, Sir Chuck. Bas from the Netherlands here. Something that's bothered me for a while is the term time.
Ooh.
Why do we still call it that? Time isn't absolute. It's relative and experienced differently depending on our motion through space-time.
true.
A photon doesn't experience time at all.
Right.
Wouldn't it perhaps be better to rename time in a scientific context? Would something like observer-related perception of reality not be a better representative of what we should call time? I'd love to hear your thoughts on this. Have a beautiful day. I don't have more time for this, Mr. Oosterveld. Okay.
I have one answer.
So it's a cool little thing that he's
Time
positing.
Time has one syllable.
Exactly.
And what he read there, count the syllables. Count the syllables.
Observer, relative, perception of reality.
It's 14 syllables.
14 syllables.
Time has one syllable.
Right, exactly.
So take that word and make it mean what we want it to mean.
And by the way,
and that's the meaning of the word.
and you can't even say what time is it with his, you would have to say, what is your observer-related perception of reality right now?
And there's certain things that we do just because it's simple. For example, our words that describe the sun and the horizon are pre-Copernican. I don't say to you, Chuck, at what time does Earth rotate such that our sight line to the horizon reveals the sun sitting out there in space? Instead I say, when sunrise?
And when sunset.
And when sunset.
All right.
And I think we're okay with that.
Yeah. Because the sun didn't really rise at all.
Well, from your point of view.
Right.
But still, it's a simple two-syllable word.
Yeah, it makes
so I don't mind precision, but not at the expense of economy.
All right. Very cool. All right, here we go. This is Zach Sweet. And Zach says, hello, Dr. Tyson, Lord Nice. Zach here from Moonsville, New York, or Munsville, New York. You've talked about knowing mathematically how to create a wormhole in previous cosmic queries and other explainers. I was wondering, what is keeping us from taking the mathematics from paper and applying them to the physical world, going from script to screen, so to speak?
Oh, I like that.
Thanks in advance.
I like that. So the problem is we're missing an ingredient.
Oh, really?
Yes. We need matter or some substance that has negative gravity.
Uh-oh.
Okay. So matter has gravity.
Right.
So matter can make black holes where you're compressing things down into one place.
Right.
And a wormhole requires you pry open the fabric of space-time.
Gotcha.
So you'd be parking this negative matter, this negative gravity substance, in a way that you pried open a tunnel through
The
space-time.
fabric of space-time
The fabric
itself.
of space-time itself.
Wow.
So we would know how to configure it,
Right.
how much of it we need,
Right.
but we don't have it.
Gotcha.
Now, there are people who say, well, what about dark energy? That's a negative gravity
Negative
pressure
gravity
in the
pressure
in the
vacuum of space. Right.
Since we don't know what it is, I'm not saying let's set up a factory to make wormholes out of it. I'm not ready to do that.
Okay, right.
And if one day we know what it is and then we can harness it and then
Right.
package it and sell it, yeah.
Yeah.
And I'm all in for wormholes. Oh my gosh.
That'd be very cool.
I want wormholes everywhere.
Yeah.
Like in the back of your refrigerator connected to your grocer.
Okay. Now you're going Homer Simpson on me.
No, I'm running low on milk to check on you.
I just reach into the refrigerator. I'm at the grocery store, grab some milk.
Oh, no,
pull
no,
it
the
back.
grocer does that for you.
Oh,
They just
he'll
keep
have
you
your
stocked.
package.
They-
He stocks your fridge
Yes,
from the wormhole.
Because they just open it up.
All right, I take it back. That's dope.
That's totally dope.
Oh, I love it.
Yeah.
Yeah.
You're never low on any supply, and they'll know the rate, and you don't have to go travel.
Yeah.
And oh my gosh.
Wow, that is fresh direct.
That's the wormhole edition
Exactly.
of Fresh Direct. So, and there's so many things that we just take for granted require transportation systems that would just be rendered obsolete with wormholes, such as on Star Trek, the transporter.
Right. Right. You don't need to deconstruct your
Dematerialize.
entire body molecularly, put it into a pattern buffer, and then beam it somewhere and recreate it,
Hoping you get the
hoping that
molecule
you get the
straight.
same pattern in the exact same
With all the
sequence.
neurosynaptic
right.
memories and everything.
Yeah, you just walk through a portal and you're there.
There you're there.
Yeah, that's
You're there.
Yeah, exactly.
It would render that solution to travel obsolete.
Yeah, but it would just ruin like the most awesome effect that Star Trek came up with, which is it's very cool.
All right, Chuck, we got time for two more.
All right,
We
well,
getting a lot done in
we
this
got a
month.
lot done today.
Wow.
All right, here we go.
Am I getting better at giving short answers, maybe?
I think the questions might be helping. No, I'm joking. Yes. Here we go. This is James Liggett. Hi, y'all. This is James from Midland, Texas,
Midland, Texas. I know Midland, Texas.
the place where baby Jessica fell down the well. James, let me explain something to you, James. Let me just help you out for a second.
No, stop.
That is not a claim to fame.
Stop.
That y'all let a little baby fall down a hole and that you couldn't get her out and that the whole country had to
whole
find
country.
about it.
The whole country
The
learned
whole
about
country learned about it before you were able to get this child out of that hole, okay?
it. I know Midland. It's the Twin Cities there. Midland, Odessa.
Midland and Odessa?
Yeah.
Okay.
Yeah. Midland. The rich folk live in Midland.
Oh, okay.
Well, back when I was there, that was
That was the
it
deal.
a very clearly understood divide
I got you.
in the landscape.
All right.
All right.
Well, James says this, since photons have no mass, how do they carry the image of their source to, say, a telescope or an eyeball? So what does it mean to say we see something because we process photons? There seems to be nothing there in a photon to process.
Ooh.
Where
Love it.
in the mass,
Love it. Love
in the massless energy of a photon is this information that we receive. This keeps bugging me, man, so please help.
Let me
Thanks.
hook up my boy from Midland.
From Midland. All right now.
Midland, Texas.
Midland, Texas.
Midland.
Mm-hmm.
So, here you go.
Here we go.
If you took all the photons and just crammed them through the one little opening and didn't have a lens,
Right.
then you would not have an image. You would just have light. That's what we do when we take a spectrum of an object.
Uh-huh.
We take all the light, funnel it down into what's called a slit, goes through the prism or equivalent device, and you see how much energy, how many photons of different wavelengths is coming from that source. It's not an image at all.
It's not an image.
You don't know what the hell the thing looks like.
Right.
But you have this many that are red, this many blue photons. This has extra photons in a particular place because an atom is sending you energy extra in that zone. And you just look at the spectrum, and that is a no image measurement of the object. If you take the photons and have a lens, then there's a photon that came from your nose, a photon that came from your toe, a photon that came from the top of your head. It's a different color because your hair is black, your skin is brown, your shoes are red, and so this will be a red photon. This will be a black photon. And the lens reconstructs where they came from onto your detector. You focus it up, the
Now you
photon
got an
lands
image.
exactly according to what the image was. So you're right. A photon alone contains no image information. You need the ensemble of photons to do so.
Wow. Dude, that was a really good question.
Yeah, and
James.
I hope he feels good about that.
Yeah, that you should be. I learned something just then. That's really damn cool. All right, well, last question. As
Last
you
question.
said,
All right.
this is Alan
So we went
Short.
from the Netherlands to Midland, Odessa, to Denmark,
Yep.
to northeast England.
Well, you're going to love this one. This is Alan Short from Thailand.
Thailand.
No, I'm joking. I'm lying. This is Alan Short from Italy.
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 Grazie.
Buongiorno, Alan. He says, with a profound admiration and the utmost awe of Professor Tyson and HRH Chuck Nice. I don't know what HRH means.
His Royal Highness.
I'll take it.
And when I was a kid, when we have juvenile sense of humor, we'd say His Royal Hiney.
Yeah, I was about to say, and that's because that's exactly, I was going to say royal hind parts, but don't, royal hiney. Okay, according to one theory, our universe is located inside of a black hole. If this is the case, where is our universe's singularity? Likewise, seeing as we have proof that our universe is expanding, why are we not seeing other black holes, presumably themselves being self-contained universes, expanding and taking over our universe? With much love. Thank you, Alan.
Brian Greene would be better to answer that, so
Yeah?
I'll give what I can.
Okay.
All right, so a couple of things.
All right.
Some equations related to a black hole apply to our entire universe,
Okay.
such as we have an event horizon. We have a horizon.
Right, we do.
It's analogous to event horizon of a black hole.
Correct.
If you look at the density of matter in the universe out to that event horizon, it is the density of matter you would need to make a black hole the size of our universe. But is it a black hole? Okay. Right. And so if it is, then there ought to be a singularity somewhere that we haven't seen. We don't know where it is.
Right.
Okay. And so...
Unless we're just the information of the black hole. Oh. And so what we're seeing is the holographic information of the black hole. The black hole is inside our black hole.
I want to be more than information. I want to be a boy. And that's Italian. That's a Pinocchio reference.
That's Pinocchio reference.
Oh, my God.
We have done it, people. That is how you stick a landing. Go to Italy and end up with Pinocchio. All right.
So that could be just where the analogy breaks between the universe and what a black hole is.
So you have a couple similarities.
But one last point, and we'll end on this.
Go ahead.
That the equations of a black hole, and there's a book here that I can dig out that will describe them, and our guy correctly noted that a whole new space-time opens up inside the black hole. If you look back at us, the future history of the universe runs its course, and a whole other space-time opens up. So each black hole would contain a universe.
A universe.
But that universe is not sharing the space-time of our universe.
Right.
So they're worried, will it fill up or bump in? No, in higher dimensions, you can fit everything.
Right. It doesn't make a difference.
That's right. You can fit it all.
That's so cool.
Just a quick thing. You have a sheet of paper that goes to infinity.
Right.
It's 2 dimensions. If I go into a third dimension, I can have another sheet of paper that goes to infinity. And it does not intersect the first.
Exactly.
In fact, I can have an infinite number of infinite sheets of paper.
One above the other.
Correct. So when you add higher dimensions, you don't have to think or worry about, stepping on each other's toes.
Cool.
It can happen.
Right.
It's not a thing.
Right. All right.
Yeah. I think we got to call it quits there, Chuck.
Well, that was a good one.
That was very hodgepodge.
Yeah, I like it. I like it when they're all over the place
all over the world.
All over the world.
All right. Very good. This has been a StarTalk Cosmic Queries Grab Bag Edition. Those are fun.
Yeah.
Love those. Chuck, thanks for doing it.
Always a pleasure.
All right. Neil deGrasse Tyson, your personal astrophysicist, reporting from my office, the Hayden Planetarium. As always, keep looking up.